Hello, welcome back to another video. I am the Hollow Nerd, and I am here to talk to you about Metroids. I had recently gotten the idea for this episode after I was thinking about Metroids on a drive to a specific house that is in multiple countries and serves pancakes. And it is multiple countries, international house of breakfast foods. Yeah, that's what it's called. Wait, no. International House of Waffles. Not pancakes. Where would you ever get that notion? Anyways, and I was talking to my friend, and I'm like, ooh, what if I did this? And so I decided to look it up. There are no videos on the Biology of Metroids. They're the canon things, but no game theory type episodes. So I decided to make the video myself. So now I'm reading a script to you guys, bored out of my mind. Let's do this. So let's start with how they float. I had 3 theories. One of them I knew would make the most sense from the start, but I had to have 2 others because, it sounds more professional like that. Anyways, I'm gonna go first, second, and then my actual theory. The first one is that they float on the magnetic fields of their home planet. Makes sense and all, I don't need much more explanation. Didn't really work, so then we moved to birds. Let me explain. They basically bend their bodies to create kind of bird wing type things. Not how they look in game or in any artwork, so no. I am not accepting this because even you can see them flying in Metroid Other M in full 3D, and that's just not how they move. So the last one I had was density. They changed their density. So they changed their density by holding the skin in the same volume while ejecting air. Okay, so they will eject air through little holes all over their body, leading them to create something closer to a vacuum, lowering their density. And because they have a low density in all the other parts of their body, they will just float. Then they expel the air to lower their density to lower than that of the atmosphere, and they'll float. Then this also explains how they move. Because I know some people are going to be like, but how do they move without bouncing off of walls? Well, you see, these little tiny holes, they can eject air. I did some calculations, and yes, this works. And, they expel air at a high velocity, and yeah, it would actually allow them to move. I was kind of surprised when I calculated it myself. What are they made of? So, this is the third part of the video. To be able to fly, they have to be made out of a pretty light material. This material also must be incredibly strong, because not even a super missile can damage it. And it also must be able to be created by biological processes. Now, before you say, what if it's some alien biological thing? Well, no, they use the same biological substances as humans because they absorb energy from... They can absorb energy from almost all life forms on Earth, meaning that they have some similarities biologically to humans and all life on Earth, mainly the way they get energy. So, obviously, they'd be able to use... They would most likely have... the same biological processes as animals on Earth. So, I was looking through this, and I thought spider silk. Some form of spider silk that is clear. About a centimeter thick. Okay? This would mean that it is still incredibly light. Well, actually about 3 or 4 millimeters, actually, would be enough to stop small explosives. This leads me to believe that they are indeed just their skin is some kind of clear spider silk. The claws, most likely made of keratin, and the organs most likely made out of just some tissue, some fleshy tissue. Next, organs. So the red orbs in the center of their bodies, I believe to be just most of the organs most life on Earth has. They don't really need lungs as they get their energy from other life forms, meaning they don't need to pull energy directly out of the air. They also, I had to come up with something for why they can metabolize beta radiation. I just said, hey, they have free electrons, they have positive ions on the skin, and that those can capture free electrons, meaning that you now have a stable atom. Anyways, they probably have some kind of ionic chemical. I don't want to get into more of that. So, and now let's go to the way they absorb energy from life forms. The way the Metroid pulls ATP out of hosts is by using little microscopic hair type things, microscopic hooks on the claws to hook onto cells in the body. The cells are then ripped apart inside, are then pulled up to the organs and ripped apart, where the mitochondria are split and the ATP ready to be used is now available. And this means that the Metroid can now metabolize off of energy it's gained from other creatures. And, well, I hope you enjoyed learning about the biology of Metroids. I'm only 13, so some of my information is my estimations, and again, I'm not that smart, so don't take my word for a lot of this, but this is my take on the matter. Nobody else has put their take on the matter, so it doesn't really matter. Anyways, thanks for watching. Be sure to like and subscribe. Goodbye. Okay, so future Daniel here. I did my calculations for how much force it would be exerting. So it would be exerting roughly 500 newtons of force, according to my calculations, if the air is weighing in at around 0.5 kilograms. That's how much air I was saying was being exerted, because air is about 1.1 kilograms per cubic meter, and I'm saying Metroid's, I was comparing them to the height of Samus in Super Metroid, so yeah, then I estimated their weight at around 8 to 10 kilograms. Wait, sorry, that's not important, that's for later. So then, if the air is then also moving, it takes 0.2 seconds to accelerate. My estimations again, 0.2 seconds, so it is meters per second, so it is going roughly, it was 200 meters per second divided by 0.2, so that's 1,000 meters per second, and then divided by 2 or times 0.5 because mass of the air. So because of the law of every reaction has an equal and opposite reaction, you're having 500 newtons pushing forward, and to calculate the speed of that, we can convert that to joules, and to calculate that, I just did the inverse of 1/2 mass times velocity squared. E equals 1/2 mass times velocity squared, to get that it was going 11.180339887 meters per second, which is roughly equivalent to 25.0097081 miles per hour. So, thank you for listening to my little math tangent. Hope you enjoyed. Have a great day. Bye. Like and subscribe. I know I said it earlier. I don't care. Thank you for watching.